Hey everyone, today we're going to pull back the curtain on one of the most useful tools in statistics, the standard deviation. Now, I know that might sound a little intimidating, but trust me, by the end of this, you'll get exactly what it is, how it works, and why it's so darn important. So let's dive in.
Okay, so imagine someone tells you that the average height of people in a room is 155 centimeters. That's a fact. It's a good starting point for sure. But what does it really tell you about the group? Is everyone in that room about the same height? Or do you have a wild mix of really tall and really short people? See, the average alone just can't tell you the whole story. And that's really the first big idea we need to tackle. The average, or what statisticians call the mean, it gives you the center point. But it totally hides a huge part of the picture, how spread out everything is.
Just look at this. We've got two groups here, Group A and Group B. And you know what? They have the exact same average height, 155 centimeters. But they look completely different, right? Group A is all clustered together, very little variation. But Group B is all over the place. We need a number, a single number, that can tell us the difference between these two pictures. We need to measure the spread.
So how in the world do we do that? Well, thankfully, some very smart people created a specific tool for this exact job. And here it is, the star of our show, the standard deviation. The fancy official definition says it quantifies the dispersion of data points relative to their mean. But let's be real. All that's saying is that this is the tool we use to measure how spread out our data is. It's our hero.
Let's boil it down even more. At its heart, standard deviation is just one number, a single, powerful number that tells you, on average, how far each measurement is from the group's average. A small number means your data is all huddled together. A big number means it's scattered everywhere. It's actually that simple.
Okay, so that's the what and the why. Now, let's get our hands dirty with the how. Let's walk through a quick example to really see this thing in action. So let's use the data from our source material. We've got a group of 6 people. We already know their average height is 155 centimeters. But if you look at each person, you can see how much their own height deviates or differs from that average. One person is 18 centimeters away, a couple are 8 centimeters away. They're all a little different. So now we've got all these individual little distances from the average. But remember, we want just one number that sums it all up, something that represents the typical deviation for the whole group. So how do we get there? It's basically a 4-step process. We've already got step 1, the mean, and step 2, the individual deviations. Now step 3 is where the magic happens. We take each of those deviation numbers and we square them. Then we find the average of those squared numbers. Squaring them does a couple of cool things. It makes all the numbers positive, and it gives a little more weight to the values that are way out there. This is actually called finding the quadratic mean. Then, for our last step, we just take the square root of that result, which brings us back to our original units. And after you run all those numbers, boom, you get 11.5 centimeters. That is our standard deviation. So what does it mean? It means that, on average, any given person in this group is about 11.5 centimeters away from the mean height. It perfectly captures that whole messy spread in just one clean, easy-to-understand number. Now, there is one little twist to this whole calculation, and it all depends on the kind of data you're working with. Let's check that out real quick. So maybe you've been looking this stuff up, and you've seen 2 slightly different formulas out there. One divides by n, the number of things you measured, and the other divides by n minus 1. And you're probably thinking, what's that all about? Why make things more complicated? Well, it all comes down to a simple question. Are you working with a population or a sample? A population is when you have data for every single member of a group. If that's the case, you use the first formula and divide by n. But most of the time, we don't have data on everyone. We just have a smaller sample, and we want to estimate what the standard deviation is for the much larger group. When you're estimating like that, you use the sample formula and divide by n minus 1. It's just a small statistical tweak that makes our estimate a little bit more accurate. All right, we're almost at the finish line. There's just one last concept you'll hear mentioned right alongside standard deviation. Think of it as its very close sibling, variance. Variance is super simple. It's just the standard deviation squared. Remember step 3 in our calculation, the number we got right before we took that final square root? Well, guess what? That number is the variance. They're directly connected. So if they're so closely related, which one should you actually use? Well, the deal breaker is the units. Standard deviation is in the same unit as your original data. In our example, centimeters. That makes it really intuitive to understand. Variance, on the other hand, is in squared units, so centimeters squared. I mean, what even is a square centimeter of height? It's much, much harder to wrap your head around.
And that brings us to the most important takeaway, which our source material sums up perfectly. Just because the units make sense and are easy to relate back to the real world, it's almost always better to use the standard deviation when you're describing your data. It just makes things so much easier to interpret. So there you have it. The average gives you the center, but the standard deviation is what really brings the data to life by showing you its shape. It's a fundamental idea you'll see everywhere, from measuring the risk of a stock to the consistency of a basketball player. So now that you've got this new power, this new way to see the world, what will you measure first?